Hello students and welcome to Unit 9, Day 10, and just like before, Mr. Gottlieb has failed to change the day number on the assignment to the correct day. So instead of Day 9, this should say Day 10. Correcting this in your notes is an indicator that you've watched the video. A couple of you are just copying your assignments off of each other. It's pretty obvious because you don't seem to have any idea what you're doing. Now, here's what we're going to do. We're going to answer some questions today, and my aim is probably not well written. It says, how do we evaluate, it's supposed to say other trigonometric functions. What it really means is evaluate trig functions for other angles. So something that isn't 0, 30, 45, 60, 90, 180, any of those numbers, anything coterminal to those, or anything else. So, for instance, there is an angle. Oh, let's read the question. Should always do that. Find the missing part of the coordinate, meaning if we have x, find y. If we have y, find x, and so on. And as well as the angle theta, given the given the, right, excuse me, let me reread this. Find the missing part of the coordinate as well as the measure of the angle theta, given the single given coordinate. I meant to write given the single part of the coordinate that is given on the unit circle. Just the fact that it mentions the unit circle means we know something about this this triangle that we're forming here. We have a triangle we're forming right here. This is 1 long. We know that this side is 0.94, which is probably an inaccurate drawing because this over here is 1, so that would imply that that's pretty small. I probably placed this point in the wrong spot, but we'll have to deal with that. This length is y, and we don't know what it is. So we can find y using one of two methods. One is the Pythagorean theorem, which we know, because the x value, which we already know is 0.94, plus the y value, which we don't know, equals the radius squared. Now, because we're using the unit circle, we could actually use what's called the Pythagorean identity, and considering that is the point of today's lesson, you should be using the Pythagorean identity, not this formula. This is more useful for when you're not dealing with the unit circle. But on the unit circle, x is cosine, so cosine square theta plus sine square theta. And do note where I write the square, that is where it goes. That's to imply that you're squaring the function, not the angle, is equal to the radius squared, which is 1. So 1 squared is just 1. Now, we don't normally write cosine before sine, so we're just going to switch that. So sine square theta plus cosine square theta is equal to 1, and that is the Pythagorean identity. And we're going to use that to figure out what the measure of the other side is. And that's what you use the Pythagorean identity for, is for finding the other side, or the other part of the coordinate. So we know that 0.94 is our x value. X is cosine, so we're going to plug that in for cosine. So cosine square theta is equal to 0.94 squared equals 1. We don't know what sine square theta is. We are going to just leave that as sine square theta. And we're just going to solve this equation. Now I'm going to use my calculator to figure out what 0.94 is when squared. So I'm just going to open the calculator app now. Oh, I did it already. I got a lot of stuff there. Let's just do it again. 0.94 squared is equal to 0.8836. So let's go back to the assignment here. So that's 0.8836 equals 1. And this is plus sine square theta, because nothing's changed here. Make sure my plus sign's pretty clear. I need to get sine square theta by itself. So I'm going to subtract the 0.8836 to the other side. Let's do the subtraction. So it's 1 minus 0.8836. And I get 0.1164 is equal to So now we've subtracted sine square theta. If I take the square root of both sides, I will figure out what sine theta is. Whoops, didn't mean to change that. Take the square root of both sides. I'm going to continue up here for space. So sine theta is equal to, I had to take the square root of that, so second x squared, that's square root of 0.1164 equals, it's a never terminating decimal, or it's a fraction maybe because it has a pattern, we can't see it, so we're just going to have to round it a little bit, so this is going to be 0.34. I'm going to go with this because the y value is also rounded here. Obviously this is inaccurate because it's approximated. So that is our y value because y was sine, right? So that tells us that this is 0.34, approximately. To find the angle, we just have to use sine inverse. So this is equal to sine inverse of 0.34. And we get that theta is approximately, second sine, 0.34. I wrote 0.6, gotta fix that, is equal to approximately 19.88 degrees. Which sounds accurate because when I made this drawing I intended for that to be 20 degrees, but my drawing didn't accurately match up with the problem. But this is how you can find the missing side using the Pythagorean identity as well as finding the angle using sine inverse. You guys are going to try the second one on your own, but I'll go over the third one with you as well. So this one we can see our terminal side is actually in a different quadrant. It doesn't change anything, it's just we have to remember that now we're dealing with a reference angle that's up here instead. So the angle we're finding is actually not the angle that was given in the circle. It's actually, we'll be working with the reference angle of this triangle here. So we know the y value, and the y value is sine, so if we're starting with the Pythagorean identity, it's sine square theta plus cosine square theta equals 1. We know y is cosine, right? Y is sine, excuse me. So sine is going to be replaced with negative 0.92, let me write that a little more clearly, negative 0.927 squared plus cosine square theta equals 1.